There we go. Hi, everybody. We're going to be doing the final section S in Algebra 1 IXL, and this is about transformations of linear functions. In general, transformations of functions involve moving them left, right, up, or down, sometimes doing reflections. I'm going to show you, I'm basically just going to explain how to do it rather than the why behind it. But I would like to mention a couple of things as we go along. So hopefully you'll stick with it. And uh, when I first start out, the examples are going to be f of x equals x, which if I try to explain why using this particular function, it's hard. The explanation won't work. So anyway, I'm just going to show you how to do it. So in this case, we want a translation of 10 units down. Now, the thing I am going to do is I am going to suggest that we think of this as an H and a K. H is the left or right, K is the up or down. And the rule is pretty simple. If we want to move it up or down, we add or subtract the K from the Y value or from the f of x value. For the H, we have to do the opposite. So that's kind of a beginning anyway, and I'll explain why we do those things if I have the opportunity. For right now, it's real simple. We're just going to go down 10 units, which is x minus 10. So we're just going to take our function that we have and subtract 10. This one's a reflection across the x-axis, which is literally changing the signs of the y's. Unfortunately, in this particular case, y is the same as x, because if you look at the function f of x equals x, it looks like this. And this is the one we're actually changing, even though it's not going to look that way. So it's negative x, because I'm changing the signs of the y's, or the f of x's in this case. This one we want a reflection across the y-axis. Now this time we're changing the sign of the x, which is weird. We had this, and what we end up with is more like this. So it's still the same idea anyway. It's still going to be negative x. Like I said, it's hard to explain using this particular example. This one is a translation 9 units right. I could explain it by showing you a picture, and you'll see that it's going to be x minus 9. One way, well, you could see it. Let's see. Here's the function, y equals x. And the function, we want to move it to the right. Well, if you notice, as we move this to the right, this value is, or the line is getting moved down to here as we move it. So it's going to be x minus 9. Now, that's not a very good explanation as to why it does that. The better explanation is that to undo the plus 9, I have to subtract 9. But hopefully we'll get a better example and I'll be able to explain why we do what we do. This one is left. So to go normally to go left, we subtract, but we have to do the opposite to take care of that. So what we're really going to do is we're going to take x plus 9. Ten units right would normally be plus 10, but it's going to be minus 10 because for the left and right, we have to do the opposite. Like I said, I'm going to show you how, but not why, until we get to more better examples. This is 3 units up. For the up and down, we just add or subtract. So it's just going to be plus 3. One way to think of it is that we're using the same sign on the y's and a different sign on the left and right. This is going to be x plus 7. And this one's going to be 8 units up, so it's x plus 8. And hopefully we'll get to a good example where I can explain why we do what we do. Okay, now this one's a lot better. Okay, for this function, what we have is we have f of x is equal to negative 2x plus 10. And what they've asked for is a reflection across the y-axis. And let me show you what happens when you reflect across the y-axis. This is the y-axis. In order to reflect across it, I am changing the signs of the x's. So what I'm going to do is I want to see what does f of negative x look like. And that's going to be negative 2 times negative x plus 10. And that's going to be positive 2x plus 10. And I could show you some more things about it, but basically that's what I did. This one's a translation 19 units down. Again, we have to do the same thing in order to make this work. It's going to be f of x equals 8x minus 9. Because we're going to subtract 19 from this function. That's going to move it 19 units down. Okay, another way to explain this is that I'm talking about the y value, which in this particular case is the f of x. So in order to move my y value down 16 units, I have to do this. And this is what g of x is defined as. So what I'm going to do is I'm going to replace the f of x with the 7x plus 7 and subtract the 16, which gives us 7x minus 9. That's a way to kind of explain it. That sort of maybe makes it a little clearer for you. I believe it was minus 9. It's nice that it's not making me do the spaces anymore. It used to make me space those subtractions out. All right, we have a reflection across the y-axis. Now, for reflection across the y-axis, we are changing the signs of the x's, remember? And why don't I show it to you? Here's negative 2x minus 4. 1, 2, 3, 4. And a negative 2x is going to look something like this. It's going to be kind of steep. This is y equals negative 2x minus 4. Now, what they want me to do is they want me to reflect this across the y-axis. So what it's going to do is it's going to go through the same point, but notice what kind of a slope it's going to have. It's going to have a positive 2 slope, isn't it? We could look at the picture of it and figure it out, but it's better to think of it like this. I'm literally taking these x's and moving them to the other side of the y-axis, and I'm taking these negative x's and moving them to the other side. So I'm changing the sign of the x. That is a better way of thinking of it. So what I'm saying is that g of x is equal to f of negative x. I'm changing the signs of the x's. And that's going to be negative 2 times negative x minus 4, which of course is 2x minus 4. And hopefully you can see that it's still going through the 0, negative 4 and has a slope of positive 2. Don't want to make a weird error as putting it in. Okay, we're going to translate 14 units up. And again, g of x is equal to f of x. And we're going to move it 14 units up. And we have negative 3x minus 9 is f of x. And we're going to move it 14 units up. It's negative 3x plus 5. I didn't get the opportunity to show you some more of the reasoning behind it, but there it is. negative 3x looks like plus 5. And it's translating up. Yes, it is. Yeah. And there we go. Maybe on another video, I'll show you why it works the way it does. So hopefully you guys will get it and keep practicing. Bye. Getting some lag here.